Welcome back, guys. This is question 6.1 of chapter 6, because from today we are going to start another chapter, which is chapter 6 of our book, and it is related to the sum continuous probability distributions, in which we will try to understand and try to solve all the questions related to the continuous probability distributions, which include uniform probability distribution, normal probability distribution, exponential probability distribution, and many others. Okay, so let us start it by solving question 6.1. so the statement of this question is: given a continuous uniform distribution, show that a mu is equal to a plus b by 2. Mu means mean of it is a plus b by 2, and sigma square is equal to b minus a whole square divided by 12, means standard deviation is equal to b minus a whole divided by 12. Okay, so we have to start it, and before starting it I have to write what? Let me write the formulas for mu and sigma square, and for continuous probability distribution we know that mu is what? It would be from the lower value of limit to the higher one, and I have to multiply with this x with f of x d of x. Okay, and for mu square of x, this is what? This is the e of x square minus mu whole square. Okay, this mu is also e of x, so therefore this can also be written as e of x square minus e of x whole square. Okay, so this is what? This is sigma square of x. Okay, so these are the two formulas which we are going to use in our question here. So this is for the mean, okay, and this is for what? This is for the standard deviation. Okay, so now before solving this question we have to keep in our mind that what should be the value of f of x. Okay, now in solving part A of my question, first of all let me write the value of f of x. So the value of f of x for the uniform distribution is 1 over b minus a for all the values of x which are greater or equal to a and less than or equal to b. Okay, this is for the uniform probability distribution, which is here from a to b. Okay, this is x, this is f of x, and this is what? This is the probability density function. Now let me solve part A of my question, and this is mu, and using here the limits which are mentioned here, which would be from a to b x, and the value of the f of x is 1 over b minus a d of x. Okay, so this 1 over b minus a is the constant term, it will be outside, so it would be 1 over b minus a, and here the remaining ones will be a b x dx, or 1 over b minus a, and the integral of x is x square divided by 2 from a to b, and ultimately what would we get? We would get 1 over b minus a, and here multiplying it with b square minus a square divided by 2. Okay, as b square minus a square, we can write here that b square minus a square is what? This is b minus a, multiply it with b plus a. Okay, so therefore writing it here, it will be 1 over b minus a multiplying with b minus a b plus a whole divided by 2. Okay, these two will cancel out, and ultimately we would get what? It would be a plus b whole divided by 2, and this is mu, and this is what? This is the proof of the part A of my question, which we have solved by these steps. Okay, so this is the solution of part A of my question. Now let me solve part B of my question. Okay, so this is part B, and the value of sigma square x as given here is sigma square x is equal to ex square minus ex whole square, while ex is given here. Okay, now in order to find the value of sigma square, what do we have to find out? We have to find out the value of ex square, and it is what? It is basically the from A to B x square f of x dx. Okay, let me write the value of f of x, which is here. So it would be x square multiplied by 1 over b minus a d of x, and the limits here again would be from A to B. Okay, so let me solve it. It will be 1 over b minus a multiplying it, this integrating this one, it will be x cube divided by 3 from A to B. Okay, or it would be 1 over b minus a, it is now b cube minus a cube. Okay, so this is what now we have. Okay, so these are multiplied together. Now we know that according to the formula, if we have this a and b, so if it is a cube minus b cube, so it can be written as a minus b a square plus ab plus b square. Okay, this is the formula which we know from the elementary mathematics. So therefore, writing it here, what would we get? It would be 1 minus b minus a, and here it would become b minus a and b square plus ab plus a square. Okay, so these two will cancel out, and ultimately, sorry, here we also have this 3. Okay, this 3 is also included here as well. So ultimately we would get what? The answer of it would be b square plus ab plus a square whole divided by 3, and this is the value for e of x square. Okay, so this is what we know now. Now let me find the value of sigma square, and it is, as we know, that it is ex square minus e of x whole square. Okay, now we know the value of e of x square, the value of mu is also here. So let me put these values. It would be b square plus ab plus a square whole divided by 3 minus a plus b whole square divided by 2 whole square, because this overall is the squared one. Okay, let me simplify it. Okay, so it would be b square plus ab plus a square whole divided by 3 minus a square plus 2ab plus b square, okay, whole divided by 4. Okay, so the LCM of it would be what? It will be 12, or according to the mathematical formulation, it would be b minus a whole square divided by 12, and this is what? This is the sigma square, and this is the proof which we were asked to find out here in this question. Okay, this was what? This was given here in part B of my question, and that is what? That is basically the solution of part B of my question 6.1. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 6.2, and the statement of this question is: suppose x follows a continuous uniform distribution from 1 to 5. Okay, so determine the conditional probability that x is greater than 2.5 given that x is less than or equal to 4. Okay, so what does it mean? Let me first draw the distribution here to see or illustrate it visually. So this is, let me call it x. Okay, and this is f of x. Okay, so if I want to draw it, so it would be what it is from 1 to 5. Okay, so from 1 to 5, this is the continuous uniform distribution, so therefore the value of it will remain the same and it will be constant here. Okay, so what should be the value of it here? What is the value which must be here? So in order to calculate it, I can use the formula here for f of x, and that is 1 over b minus a. Okay, so here the value of b is 5, the value of a is 1. So let me write it 1 over 5 minus 1. So this is 1 by 4. Okay, so therefore this one is what? This one is 1 divided by 4, which will remain the same. Okay, so this is what we have found out. Now on the basis of it, this is the conditional probability, but we can here follow two methods to solve this question. Let me solve it by using the first method, and in that method, let me have it here. In that method, let me call it method number 1. In that method, I have to use the probability that so x is greater than 2.5 given that x is less than 4. Okay, so what is this? According to the conditional probability, we have to write x is greater than 2.5 and the probability that x is less than 4 divided by the probability that s is less than or equal to 4. Okay, here we can see that these two are connected, so therefore we can write them combinedly as what? Okay, let me write it in combined method. So it would be x is greater than 2.5 and less than or equal to 4. Okay, so there we have it here. Okay, so in order to find both of them, what do we have to do? We have to use the similar formula for finding the probability density function here. Probability that x is less than or equal to 4, it will be from 1 to 4, because all the values from 4 to 1 here will be the ones which are included in this distribution. And also here, what do we have to do? Here we have to write here f of x dx. Okay, we have already found out the value of f of x, so therefore let me write it here. Okay, the value of it, so it would be 1 over 4 d of x, and finding it out, it would be 1 by 4 and x 1 4. Okay, or simplifying it, what would we get? This would be 4 minus 1 divided by 4, so it would be 3 by 4, the value of it here. Okay, also the probability that x is greater than 2.5 and less than or equal to 4, here the only difference would be to make it from 2.5 to 4. Okay, and also the fx will remain the same and it will be here. Okay, also writing it, we will get the similar one, but here the limits would be from 2.5 to 4. Okay, and it would be what? 4 minus 2.5 is 1.5 divided by 4. Okay, taking both of these values now. Okay, so it is what? Let me write it here. So 1.5 divided by 4 divided by 3 over 4, these two will cancel out, it would be here. So ultimately we will get 1 by 2. So the answer of it is what? The answer of it is 1 by 2. Okay, so that is what? That is the solution by using the first method. In second method, let me draw the distribution here. This is the distribution. Okay, So this is the distribution, but as we are not given here in this condition all the values upper than 4, so therefore we are confining ourselves from 1 to 4. Okay, so these are the values. Now similarly here, this is what this is, this one which we have seen here, which are x is less than or equal to 4. Similarly, according to the other condition, this is greater than 2.5, while it should confine between 2.5 and 4. So therefore it will be here as, let me write it from 2.5 to 4. Okay, so these are the two areas. This one is the first, let me call it A, and this one is B. Okay, so in order to find the probability that x is greater than 2.5, given that x is less than or equal to 4, here we can use these two areas. Okay, so in these two areas, the higher one or the area we want to find here is this one. So therefore it would be 4 minus 2.5, which is the length, multiplied it with this height. Okay, this is the length and this is the height, so this is 1 by 4 as we have already found out. And similarly, this is the total area. Okay, so it would be 4 minus 1, multiplying it with this height. Okay, so it was 1 by 4 as well. These two will cancel out, and from it would be 1.5. This is 4 minus 1 is 3, so ultimately we would get the answer of it 1 by 2 as well. So the two answers are equivalent with each other. Okay, what we have to keep in our mind that here we have used the conventional method, in which this is the area whose probability we want to find out, while this is the total area. And by using the conventional method or the conventional principle of probability, that the probability of an area is equal to the subset of the area divided by the total area. Okay, so we have used the similar formulation here and we have found the answer which is similar one as that of the original one. Okay, so that's it for today, in which we have seen the solution of question 6.2. If you have any question, you can ask me in the comment box. See you soon. Welcome back guys, this is question 6.3. And the statement of this question is: the daily amount of coffee in liters dispensed by a machine located in an airport lobby is a random variable x having a continuous uniform distribution with a equal to 7 and b equal to 10. Means it is like here a is 7, b is 10. Okay, and this is like here. Find the probability that on a given day the amount of coffee dispensed by this machine will be A, at most 8.8 liters, B, more than 7.4 liters but less than 9.5 liters, and C, at least 8.5 liters. Okay, so we have to find that what are the required quantities. A, we have to find the probability that the coffee dispensed by this machine will be, which is, let me represent it with x, is at most 8.8 liters, means less than or equal to 8.8. Okay, b is more than 7.5 liters, means x is greater than 7.5 liters and less than 9.5 liters. Okay, and C is what? At least 8.5 liters, means P of x greater or equal to 8.5 liters. Okay, so we have also solved a question like this one in our previous video, which was 6.2, and we have used two methods. The first method was something which has used the f of x, which was what? Which was 1 over b minus a, which is here 10 minus 7, because b is 10, a is 7, so it would be 1 by 3, means the probability or f of x it has is 1 by 3. But here we have different quantities, and the first one is 8.8. So the higher limit here is 8.8 while the lower limit here is 7. Okay, so therefore now solving it, let me use this color. So if I have here this 8.8, okay, so what is this? We have to find the probability of this area, okay, while the overall area is here. Okay, so in all of this area, finding this area, what do we have to do? We have to multiply this width with this height. So it would be 3 multiplied by 1 by 3. Okay, or it can be the similar one in the numerator and the denominator, because the height of both of them will be the similar ones. So numerator and denominator will cancel out. So therefore we have to rely upon these lengths. Okay, so therefore this is the length we want to find the probability of. So 8.8 minus 7 divided by 10 minus 7. Okay, so it would be what? It would be 1.8 divided by 3. Okay, so this is basically the answer of part A of my question, and this is what? This is 0.6. okay, this is for part A. For part B, we have to use what? Let me use this green color. Okay, so here we have the lower limit given and the higher limit given is as well. So the lower limit here is 7.4. so let me have here 7.4, and this is 9.5. okay, so this is the area, okay, which we want to find the probability of, while the overall area is again in this bluish color. So therefore having here this area, so it would be 9.5 minus 7.4 divided by again the overall, which is 10 minus 7. okay, so it would be what? It would be 7 and 2.1 divided by 3, so it would be 0.7, and that is basically the solution of part B. In part C, we have to find the probability that x is greater or equal to 8.5. so let me use another color for it, and let me have here this red color. okay, so now 8.5 is given, so 8.5 is, let me have here this 8.5, and it should be greater than this, so it is now here. So we have to find out the probability of this area as compared with this overall area, which is here given in this blue. So therefore it would be 10 minus 8.5, which is the higher value, minus this lower value, divided by 10 minus 7. okay, so it would be what? It would be 1.5 divided by 3, so it would be 0.5, and that is basically the solution of part C of my question. okay, there is also another method which is based upon this f of x, which we have solved in our previous method as well as the method number 1, but this was based on, all of these are based upon the method number 2, as we have done in our question 6.2. so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 6.5, and from today we are going to start the normal distribution. okay, so what is the normal distribution, how to proceed in it? So in dealing with the normal distribution or standard normal distribution, we are going to discuss first the z distribution and z distribution table. okay, so on the basis of it, what it does is that it basically gives us the probabilities for the probability that x is less than or equal to some z value, and give you the answer of it, and that is tabulated in the form of the z distribution table. So here we have all these parts of this question. So what do we have to do? This z is basically the form of the standard normal distribution, where the mean of it is 0 and variance is 1, which basically give me standard deviation, which is also 1. Okay, so this is what, this is basically the standard normal distribution. So what do we have to do? Let me first go through the statement of our question and then proceed with it. Okay, so given a standard normal distribution, find the area under the curve that lies a to the left of z equal to minus 1.39. Okay, so let me first solve this part A, and here we have to do what we have here, this normal distribution. Let me have here the 0, this is what we have here, and here we have to find what, this is the value minus 1.39. let me have here this one minus 1.39, and what do we want to find out? We have to find the area under the curve that lies to the left of z minus 1.39, means the area is where, the area is to the left of it, which is here. Okay, so this is what, this is to the left of it, so therefore this is what, this is the probability that x is less than or equal to minus 1.39. okay, so this is what, this is also equivalent to the probability that z is equal to minus 1.39. we have to find this value. So for it we have to use what, we have to use the z distribution table. Okay, so for it let me move to the z table. So this is the z table, and here we can see that these are all the values of the z, which ranges from minus 3.9 to 3.9. okay, so here we have to find what, here we can see that we have to find the value of minus 1.39. so therefore let me first go to minus 1.3. so this is minus 1.3, while this is for 9. okay, we can see that this is the column of 0.09. so here this is the value which we have, so it is 0.08226, 0.0826, and that is what, that is basically the solution of part A of my question. okay, so you have understood how to find it out, how to use the z table, and this is what, this is the area which is to the left of it. Now let us move to part B of my question, and part B is to the right of z 1.96. okay, so what's the difference? This is to the left, while if I have this distribution which is the z distribution. okay, so this is what, these are the tails, and here let me have this 1.96, let me have here this value 1.96 here. okay, and what do we want to find out? We have to find out the area which is to the right of it. okay, so to the right of it is this one. okay, which is what, which is the probability that x is greater than 1.96. so this can also be 1 point, the probability that x is less than or equal to 1.96. why? Because I want to find out this area, but in the formula and in the table we have these values. so once I will find all these values and I will subtract it all from this area, what would I get? I would get this area. okay, so let me write these values. so it would be 1 minus the probability that z is equal to 1.96. okay, let me find these values. so it would be the probability that z is equal to 1.96. so let me consult the z distribution table here as well. so it is 1.96. so 1.96 is, this is 1.9. okay, and for 6 this is the column which is here. okay, this one is this fourth one from the right side. okay, so 1 2 3 4, so this one is here. so this is 0.975. okay, 0.9 what 975. okay, so subtracting it from this one, what would I get? 0.0250, and that is what, that is basically the solution of part B of my question. okay, so this is for part B of my question, and you have understood that we had to find this area, and for it we have to subtract for it all this area which is here. So subtracting this one from 1, we have got our answers. Okay, so let me remove all these ones and let me move to part C of my question. In part C, we have to find the area between z equal to minus 2.16 and z equal to minus 0.65. So again, let me have this distribution here. Okay, so here this is minus 2.16. Let me have here this one minus 2.16 and up to minus 0.65. So let me have here minus 0.65. Okay, so what do we have to find out? We have to find the area which lies in between these 2 points. Okay, so these are what? This is the overall area. This would be the overall area from here to here. This would be probability that z is less than or equal to minus 0.65, while this one would be it less than minus 2.16. Okay, so in order to find this area, let me use this color. In order to find out this area, what do we have to do? From it we have to subtract this one, so all of it will be removed and we will get all this area. Okay, so what it would be? It would be the, this is C, the probability that x is greater than minus 2.16 and less than minus 0.65. So it would be the probability that z is equal to minus 0.65 minus the probability that z equal to minus 2.16. Okay, so let me find out these two values. So for it, again, the z table, the first value is minus 0.65. So here minus 0.6. Okay, so this is minus 0.6, and for 5 we have to see the column. This is the column, and here this is 1 2 3 4 5, fifth one from the right side. Okay, so 1 2 3 4 5, this is fifth from the right side, so it would be 0.2579, 0.2579 minus the probability that z equal to minus 2.16. Okay, so minus 2.16 is, this would be minus 2.1 column, and the sixth one would be 2.16. This is the sixth one column, so it would be 0.0157, 0.0158. Okay, so subtracting from them, okay, and performing this operation, what would I get? 0.2424, and that is what, that is basically the solution of part C of my question. Okay, so this is for part C. For part D, you have to do what? Okay, again the similar formulation we have to find to the left of 1.43. This is what we have here. Okay, this is here, and this, let me have here this 1.43, and we want to find the area of what? We have to find the area of all these. Okay, so this is to the left of it, so therefore it would be the probability that x is less than or equal to 1.43, which is the probability that z is equal to 1.43. You have to consult the table, and in the column, in the rows you have to see the value for 1.4, and in the column you have to see it for 0.03, and you will get the answer of it. Okay, to the right of z equal to minus 0.89, which is for part E. To the right of what? Minus 0.89. so let me have it here, minus 0.89. okay, and this is what? This is basically this area to the right of it, but we have in the table this area, we can find out this one, so therefore here the probability that x is greater than minus 0.89, this is 1 minus the probability that x is less than or equal to minus 0.89, okay, and it would be 1 minus probability that z equal to minus 0.89. You have to do it and you will get the answer of it. The last part is between 0.84 and z equal to 1.75, and this is the similar one as of part C, and you have to do it yourself, try it, and if not, I will solve it in our upcoming video as well. So that is all about the standard normal distribution, the z distribution, and all the things which you should know. In our upcoming video, we will try to solve all the questions related to the normal distribution. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 6.6, and the statement of it is find the value of z if the area under a standard normal curve is a to the right of z is 0.3622. okay, so in solving it, let me have it here, and the area under it is, let me have this curve, okay, and the area to the right of z is 0.3622. okay, so let me have here this, so let me have here this z, and to the right of it, this one, this is 0.3622. okay, means we know that the probability that x is greater than z, this is 0.3622, while the table we have is made for the probability that x is less than z, okay, less than or equal to z. We have to convert it in terms of this one, so therefore this one is basically what, if we want to find out this whole area, okay, this is what we will find it out, and from it we will subtract it, and then we can find out this value. So therefore the value for x is less than or equal to z, that is 1 minus the probability that x is greater than z. okay, the value we know is this one, so it would be 1 minus the probability that x is greater than z. So this is what this is given, and this is 0.3622, and that is the value of probability that x is less than or equal to z, or we can also call it for the value which is less than z. okay, this can be interpreted in both ways. This can be written as less than or equal to z, this can be written as less than or equal to z, because in the continuous probability distribution there is very small distinction between the equal to and less than. Both of them can be included here. okay, so let me subtract it from 1. So subtracting it, we will get what, it would be 0.6378. okay, so this is the value of probability that x is less than or equal to z. okay, so we know all these values which are now here, and let me indicate them by using this color. We know all of them, and this is what here we know this area. Now on the basis of it, we want to find out the value of z, which is here. So in order to find the value of z here, we have the table. So to find the table, this would be what, this would be phi inverse of 0.6378, means in the table we have to go to find that where the value that is 6378 is written, and we have to find the corresponding z value. okay, so let us move to the table and let us find the value where the value 0.6378 is written. So this is the table. okay, and let me have this value. Let me first find out the value which is 0.6378. so you can see that these are all the smaller values. okay, we have to find those values from here. These are the values, while these are the values of z which corresponds with them. These are after the decimal values, these are before the decimal values. okay, we have to find them out. okay, so let me move down 0.6378. so let me see that where 0.3678. so this is the value which is closely relevant with it. This basically corresponds with these values. So it is 0.3 and the other value 0.05. So 0.05, so adding them we would get 0.35. okay, so let me move here, and the value of z is what? That is 0.35, and that is basically the solution of part A of my question. Okay, so you have understood how to solve it. Now in part B, let me move to the part B. To the left of z is 0.1131. so again we have this distribution, and this is the z distribution. We have here this z, and to the left of it is what? To the left of it is all of this, and this is the value of z, and this is 0.1131, means this is the probability that x is less than or equal to z, and this value is already given, 0.1131. so which corresponds to that. In order to find the value of z, we have to find the inverse of 0.1131. so how to find the inverse of it? We have to move to the table and see that what is the value which corresponds with the value of z, which gives me this 1131. so 0.1131, so this is the smaller value. So let me see it, 0.1131. yes, this is the value, you can see that. So it is now here, the higher value is minus 1.2, while the decimal value is, after the decimal value, 0.01. okay, so it would be 0.01, so it would be minus 1.21. okay, so minus 1.21. so let me write it here. So minus 1.21, this is the value of z. okay, so this is basically the solution of part B of my question. Let me remove them now. For part C, between 0 and z with z is greater than 0 is 0.4838. what does it mean? That we have here this distribution. okay, so it is from this point, which is 0, up to this, which is z. so this is now the area which is here, and this is what? 0.4838. okay, we want to find out this value of z, and we have previously seen that in order to find this value, what did we do? We have subtracted the value which is x equal to z from the value at x equal to 0, and then we have got this value which is 0.4838. okay, we have solved it in our previous videos. Now we know that this value is here. So this was what? This was x is less than or equal to z, while this one, you can consult the table here, and here you can see that this is the value which is 0.00. this is 0.5. let me write it here. so it would be 0.5, so it would be 0.4838. so it would be the probability that x is less than or equal to z. Adding 0.5 to the both sides, what we would get? We would get here 0.5 plus 0.4838. okay, adding them together, what would we get? It would be 0.9838. okay, so this is what we have found out. Now in order to find the value of z, again the similar formulation, which is the inverse of 0.9838. okay, so what do we have to do? Let us move to the table. So 0.98, which is where? 0.9838. so 0.98 is here. okay, so this one is the value which is 0.9838, which is with 2.1 here. okay, and this column is at what value? This one is 0.04. so 0.04, so it would be 2.1. 0.14. So therefore the value of z here is, let me write it here, the value of z is 2.14, and that is basically the solution of part C of my question. Now for part D, what do we have to do between minus z and z with z is greater than 0 is 0.95, means we have here this distribution. Okay, we have here minus z, we have here z. Okay, and the values or this area between minus z and z is what? This is 0.95 or 95% of this, means these two tails which are here, this one and this one, these combinedly are giving me the remaining 5%. Okay, so these two are, means the probability that x is less than or equal to minus z plus the probability that x is greater or equal to z, these are 0.05. Okay, so therefore the value here, okay, it would be what? If we want to find out all these value, because after finding it out we can consult the table, so it would be this area which is 0.95 plus this area which is 0.025, and this one is 0.025, because adding them both will give me this area which are here. Okay, you have got my point. So once we will find the probability that x is less than or equal to z, it would be what? This one which is 0.95 plus this one, okay, which is the tail area, so it would be 0.025. and also we have written them like this because this is a symmetrical curve to the both sides of the 0, so therefore it would be 0.975, and it is for probability that x is less than or equal to z. Okay, now in order to find the value of z, it would be again the phi inverse of 0.975. okay, let me find it out from the table. Okay, 0.975, so 0.975 is here. Okay, this is the value, so it is here 1.9. okay, and in the column it is 0.06. okay, so 0.06, so it would be 1.96. okay, so the answer of this z is what? Let me write it here. This is 1.96, and that is what? That is basically the solution of part D of my question. Okay, so that's it for today, in which we have solved part A, B, C and D of question 6.6. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 6.8, and the statement of this question is: given a normal distribution with mu equal to 30, which is the mean, and sigma is equal to 6, which is the standard deviation. Okay, so let me have here this distribution. Let me have it here. Okay, this is what the distribution which we have, and here the mean is 30 while the standard deviation here is equal to 6. okay, so on the basis of it, what do we have to find out? The normal curve area to the right of x equal to 17. okay, so let me have here 17, and we want to find out this area which is, now here let me have this 17, and we want to find out all of this area. So the easiest way to do is to first convert it into the standard normal distribution, in which this one would be just like 0 and the standard deviation of it will become 1, and then finding out the area by using the probability distribution table, which is called the z distribution table. okay, we know about it, and then finding it out is very easy because this is the z domain. Okay, Okay, so now let us first solve part A of my question, and here first of all transform all of this into the z table, and in order to find it out, we know that for this value of x equal to 17, the value of z would be equal to x minus mu divided by sigma. Okay, so let me first put the value of x, which is 17, the value of mu is 30, and the value of sigma is 6, so it would be minus 13 by 6. Okay, so let me calculate it. It would be minus 13 divided by 6, so it is what? It is minus 2 point, so this is minus 2.17 as given it. Okay, so now this is the value of z, which is here, and this is, let me have it here, let me use another color for it. It is, let me have it here, minus 2.17, and according to the statement of it, we have to find this area which is to the right of it, and this is all the area which is z, or this is greater than minus 2.17. Okay, so in order to find it out, we have here the probability that z is greater than minus 2.17. we have to find it out, but in order to find out this area, we have a table which is in the form of z distribution table, and there we have all the values here, and those all values are written in the form of z less than or equal to minus 2.17. okay, because all of those values are basically the probability that x is less than or equal to z. If we have a formula in this form, we can use the z distribution table. So therefore this area is basically the total area minus this one. So therefore the total area, we know in any probability distribution it is 1, and from 1 we have to subtract this area, which is what? Probability that z is less than or equal to minus 2.17. you can write it z, you can write it x, whatever you want, because these are the values of z. So here I have been using this z. Okay, so let me find out the value of minus 2.17. so let us consult our table. Okay, so this is minus 2.1 in the column. Okay, and the 7 one was here, the 7 is this one, this is the column, so it is 0.015. so let me write it 0.015, and let me subtract it from 1. okay, 1 minus 0.015. okay, so it is 0.985. so 0.985, and that is basically the solution of part A of my question. Okay, so you have understood that how to find out the solution of part A. In part B, let me change the color of it and let me solve it here as well. In part B, the normal curve to the area left to x equal to 22. So let me have here x equal to 22. First of all, let me convert it to the z. So to convert it into the value of z, it would be the similar formulation. So 22 minus 30 divided by 6, so it would be minus 8 divided by 6. okay, so it is what? 8 divided by 6, it would be minus 1.34. so minus 1.34, which is value of z. Now we have to find the normal curve area to the left of it. Okay, so that is the left, so therefore we don't have to use another formulation for it. So therefore it is probability that z is less than or equal to minus 1.34. we have to find its value, and let me consult the similar table for minus 1.34. So for minus 1.3, this is minus 1.3, and for 4 the column is this one. Okay, this is the column minus 1.34, so it is 0.090. okay, so 0.090, and that is what, that is basically the solution of part B of my question. Okay, you can look at it, and this is here. In some books it is also written as this one, but because I have estimated it as 1.34, so therefore this is 0.090. okay, so that is the solution of part B of my question. Let us move to part C, D, and E. So in part C, the normal curve area between x equal to 32 and x equal to 41. So this is part C, and this is x equal to 32 and x equal to 41. What do we have to do? We have to convert them both into the z value. So z would be equal to x minus mu divided by sigma. So the value of z is x minus mu divided by sigma, where mu is the mean, sigma is the standard deviation, as we have studied in our previous video. So therefore let me apply it here. So it would be 32 minus mu, which is 30. okay, 30 divided by the sigma, this sigma, which is 6. okay, so it is here, and this is, let me call it z1, and let me call it x1, this is x2. So the value of z1 would be equal to 2 divided by 6, which is 1 by 3. So 1 by 3 is 0.34. okay, similarly for x2, this is, let me have here z2, it would be 41 minus 30 divided by 6. okay, so the value of z2 would be 41 minus 30 is 11 by 6. So 11 by 6 is what? This is 11 divided by 6. okay, this is 1.84. 1.84. So these are the two value of z, and we have to find out the area in between them. okay, so if we want to find out the probability that z is greater than 0.34 and less than or equal to 1.84, how to find it out? We know that it is probability that z is less than or equal to 1.84 minus the probability that z is less than or equal to what? 0.34. okay, so these are the two values, and we have to find them out by using the z distribution table. This is basically z2, this is basically z1, and let me consult our table for 1.84 and 0.34. so for 1.84, let me move to the 1.8, this is 1.8, and for 4 the column is this one. okay, so 1.84 is 0.967. so 0.967 minus the probability that z is less than or equal to 0.34. so 0.34 is, this is 0.3, and 4 is this one, so this is the value 0.633. so 0.633. okay, let me calculate it. so it would be what? 0.967 minus 0.633, it is 0.334. 0.334, and that is basically the solution of part C of my question. okay, in many books you would see that this answer is different than those, because I have approximated 3 repeating 3s as 4s and repeating 3s as 4s here as well. So therefore there is a difference. If you will calculate it like 0.33 and 1.83, it will be the similar one as given in those solutions, but this one is for the repetitive values of 3, which I have estimated as 4. Okay, so that is the solution. Part D of our question is what? The value of x. We have to find the value of x that has 80% of the normal curve area to the left. Okay, so let us have this normal curve. Okay, and let us have here the value where almost 80% of it is at the left, and it is also known that this is a normal curve. So as the overall area is known and we have been using the z distribution here, so therefore we know that according to the z distribution, x is less than or equal to z. That value is given and that is 80%. So let me call it 0.80. Okay, so this is known because all of these values are on the left side, and this is the value which we can use in the z distribution table. Similarly, in order to find the value of z, which is here, okay, let me use another color. In order to find out this value, what do we have to do? We have to find the inverse of 0.80. Means in the table we have to look for the value of 0.80 and the corresponding value of z will be our answer. Okay, so let us consult the table, and here let us find the value 0.80 or the nearest one. Okay, so let me have here, so 0.80, let me have it. So this is the nearest value, 0.799, which is around 0.80, and the value it has is the corresponding value is 0.8 in the row, and in the column we have 0.04. so 0.04, adding them together we will get 0.84. okay, so the value of z is 0.84. so the value of z is known. Now in order to find the value of x, what do we have to do? In order to find the value of x here, we know that previously we have calculated the value of z from our value of x was x minus mu divided by sigma. So on the basis of it, we can use the value of x is mu plus z multiplied by sigma. Okay, so we know the value of mu, we know the value of sigma. Let us put those values here. So x is here, 30 is mu. Okay, the value of z is here 0.84, multiplying it with sigma, which is 6. Okay, so it is here we have. Let us calculate it. So it would be 0.84 multiplied by 6, so it would be 5.04 plus 30, so 35.04. that is the value of x and the answer of part D of our question. Now let us proceed to part E. The two values of x that contains the middle of 75% of the normal curve area. Okay, so let us first remove it. Okay, so this is part E, and let me use the similar procedure what we have used in a previous question was this. Okay, and let me have here this x, let me call them z and minus z, and the area here is what? The area in between them is this one, and this is around 75%. This area is 75%, means the overall area here was basically what? This was the remaining 25%, means this is what plus this one. Let me call this one a, this one b. So this a plus this b, this is the remaining 25%, means what are those areas? This area is the what? This one is the probability that x is less than or equal to minus z plus this b is here, the probability that x is greater or equal to z, this is the 25%. Okay, similarly, as this is a symmetrical curve, therefore each area here would be what? It would be 12.5%, and this is also 12.5%. Okay, so this is it, half of the 25%. So suppose here, if I want to use this value, because this is the negative of it, if I want to use this value, what can I use? I can use all the values which are less than this. So therefore, in order to use this value, let me use this black color. So here it will contain what? It will contain this area plus this area as well. So therefore, the probability that x is less than or equal to z, that is equal to the probability that this one and this one and this one is basically 75% plus the remaining this 12.5%. So it would be 87.5%, which is what? In terms of probability, it would be what? It would be, this is 0.75 plus 0.125, so it would be 0.875. Okay, so this is what we have here, and this is the probability that x is less than or equal to z for this z. Now in order to proceed, let me use this color. In order to proceed here, we want to find the value of z, which is here. So this z is the inverse of 0.875. okay, let me use the table here to find the value of it, which corresponds with the z value. So let me use the table, and here let me search for 0.87. so 0.875. okay, this is the 0.875. okay, so it is 1.1 in the row, and in the column, what is it? It is 5. So 0.05. So it is 1.15. So the value of z is 1.15. this is the value of z, and similarly the value of minus z would be minus 1.15. so these are the two values which are here. So this is minus 1.15 and this is 1.15. in order to find the value of x from them, we have the formula, and that is the z equal to x minus mu divided by what? Divided by sigma. okay, so now in order to find the value of x from it, it was what? It was mu plus sigma z. okay, this is what we have found in our previous question. So now here the value of x1 would be, the value of mu is given, that is 30, plus the value of z is 1.15 multiplied by what? Multiplied by 6. okay, this is for x1. so the value of x1 would be what? It would be 1.15 multiplied by 6. so this is 6.9 plus 30 is 36.9. this is for x1, and for x2 we have here what? Let me move down somehow. For x2 we have here 30 plus value of z is now minus 1.15, and multiplying here with this 6, which is sigma. so this would be 30 minus 6.9. so this would be x2, and the value of x2 is 30 minus 6.9. this is 23.1. so 23.1, and that is the value of x2. okay, means in the distribution where this is now 30 and the standard deviation is 6, this is x2, this is x1, so it is 23.1 and this one is 36.9, and it basically holds this area which is almost 75% of the total area. So you have found this answer from the procedure we have followed here. Okay, so that's it for today, in which we have seen the remaining parts of question 6.8. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 6.9, and the statement of this question is: given the normally distributed variable x with mean 18 and standard deviation 2.5, find a probability that x is less than 15. Okay, so let me first solve them, and let me solve part A first. Okay, so here we want to find out the probability that x is less than 15. So first of all, this is basically the value of x, and we need to convert it to z to find out the probability by using the z distribution table. So therefore we know that z is equal to x minus mu divided by sigma, where mu is the mean and sigma is the standard deviation. So let me put all these values. X is 15, mu is what? Mu is 18, divided by the sigma, which is 2.5. So it is 15 minus 18 is minus 3 by 2.5. Okay, so let me have it here. So 3 divided by 2.5, it is 1.2. So this is minus 1.2. So therefore, in terms of z, we now have to find out the probability that x is less than minus 1.2. So let me do what? Let me use the z distribution table. So in this z distribution table, minus 1.2 is where? Okay, so let me go to minus 1.2. So here it is. This is minus 1.2, and in column we have 0. So this is what? This is what we wanted to find out. So 0.1150. So the answer is 0.1150. That is the solution of part A of my question. Now in part B, the value of k such that probability that x is less than k is 0.2236. So here we have this one. So the probability that x is less than k, this is 0.2236. So first of all, let me find out the corresponding value of z for this value. So for that, we have to do what? If you want to find out the value of z, we have to take the inverse of 0.2236, and this is from the table that we need to find out this value, and then we will write the value of z which corresponds with this value. So let us move to the table as well. So 0.226, we have to look for it here. 0.226. So this is what? This is the 0.2236, and this is for a minus 0.7, and the column it has is this one. This is the 0.6 column, so it would be minus 0.76. Okay, so let me write it here. So the value of z for it is 0.76, but it is negative. Let me see that. Yes, this is minus 0.76. So the value of z is known. Now in order to find the value of x from it, we know this formula. Okay, and from it, if you want to find the value of x from the z, it would be what? It would be mu plus z multiplied by sigma. So let me put these value. Mu is 18, okay, plus z8 minus 0.76, and the value of sigma is 2.5. okay, let me have it. So it would be 18 minus 2.5 multiplied by 0.76, so it would be 1.9. okay, So minus 18, so this is 16.9, and that is the value of x which we wanted to find out, and that is the solution of part B of my question. In part C, we have to find the value of k such that p is greater than k, and for this value, and here we need to find out the value of z for it, and for it we need to find it by the probability that x is greater than k. This would be 1 minus probability that x is less than k, because this is the value, this is the item for which the table has been created. Okay, so therefore we need to find it in terms of this one. So therefore it is what we know, this value. So therefore the probability that x is less than k, it would be 1 minus the probability that x is greater than k, writing it this value. So it is 0.1814. okay, once you will find this value, you will have to process it again by this formulation. You have to find the value of z, and after finding the value of z, you have to use the same procedure which we have done for part B of our question. Okay, so that is part C. In part D, you have to find the probability that x is greater than 17 and less than 21. So let me move down somehow. Here this is part D, and here we have to find the probability that x is greater than 17 and less than 21. We need to find it out in terms of the probability that x is greater than z1 and less than z2. okay, these are the two values of z. So in order to find the value of z1, we have here x1 minus mu divided by sigma, and here this is z2, this is x2 minus mu divided by sigma. This is what, let me use this color, this is x1, this is x2. okay, you have to put it here, you have to put this one here. okay, let me solve it. So solving it, what would I get? Here it would be z1 is 17 minus mu is what? Mu is 18. okay, divided by 2.5, which is the value of sigma. Here it is also given, and in the question it is also given here as well. okay, so similarly for z2, we will have here 21 minus 18 divided by 2.5. it is minus 1 over 2.5. this is z1. For z2, we have 3 over 2.5. okay, so 3 over 25, let me calculate it. Here we have, so 1 over 2.5, this is 0.4. z1 is minus 0.4, and z2 is 3 over 2.5. so 3 over 2.5, this is 1.2. so 1.2. so therefore we need to find out the probability that x is greater than minus 0.4 and less than 1.2. so which is what? Which is basically the probability that x is less than 1.2, and from it we have to subtract the value that x is less than minus 0.4. okay, these two values are where we have to look for them in the z distribution table, because this is z, so therefore we have to utilize the z distribution table for probability that x is less than 1.2. let me have it here. so for 1.2, this is here. okay, so this is now 0.8849, so 0.885. okay, minus probability that x is less than minus 0.4. so minus 0.4 is, this is the minus 0.4, and this is the corresponding value 0.3358. so 0.33 6. Okay, let me subtract it from it. So subtracting it, 0.885 minus 0.336, this is 0.549, 0.549, and that is what? That is basically the solution of part D of my question. Okay, so that's it for today, in which we have seen the solution of question 6.9. If you have any question, you can ask me in the comment box. See you soon.